So using the idea that we did last time, we have x plus 2 times x plus 2. We're using our distributive property, representing it in this little table or box. I combine my like terms, and I get x squared plus 4x plus 4. Now, that's easy to do. You can do everything in this lesson. Like you could, I guess you don't do this, but you could just go and do the rest of it right now this way. You can do the rest of it that way, okay, guys? You could just, whatever method you were using last time for homework, you could keep going. But there's a little pattern we notice here. Okay? So there's a little bit of a pattern here that we see, and the pattern is this. We square the first term, and we square the second term, just like you normally do, to get x squared and 4. And then there's a special pattern here from the middle. Notice that these two are both the same. So what we're doing is taking the product of the middle, taking the product of the x and the 2, which is 2x, and then we're doubling it. So the question is, does that work every time when you have something squared? Let's just see here. This first term would be x squared. What would the last term be when you square the negative 5? Except it's negative 5 times negative 5. So positive 25. As a matter of fact, I don't care if this is a minus sign or a plus sign in the middle. It's always going to be positive on the last term. Because a positive times a positive is positive, and a negative times a negative is still positive. Now, if I'm going to have, think about the box here. On this one, I'm going to have a negative 5x in this position and a negative 5x in that position. So they're just going to get added together to equal negative 10x. So with these special cases, what you can do is multiply the x and the negative 5 together, which is negative 5x, and then double it.
Oh, yeah.
To equal negative 10x, and that will always go in the middle term. That's the shortcut. That's the pattern for perfect squares. In other words, when you have two binomials that are exactly the same. Let me show you this. You got to see some more examples of this. I think it'll make sense. We're going to skip these two for now and do some more that are squared. We'll come back to these once we've consolidated this first one. So if you go to the next page here, squaring a binomial. X plus 4 squared, we're going to square the first term, which is x squared, right? You guys see how I'm getting the x squared?
Yeah.
No? If I were to write this as x plus 4 times x plus 4,
What the heck, mister?
that's going to, x times x is going to give me an x squared. And then my last term will be a 16. You see how I'm getting the 16? 4 and the 4.
Oh.
But then here's where we want to kind of shortcut this a little bit. What's my middle term going to be according to the little shortcut I just showed?
2.
It's 8x.
8x.
How do you get 8x?
Because 4 times 2, bro. I have no idea what you just did, but
If you take,
you just add 4 and 4.
you add 4 and 4, yeah. So you take the x and the 4 gives me 4x, and if I double that, that's how you get the 8x. That's all you have to know.
This is the one thing I learned last year is if you add the two numbers, you get the middle one. Multiply them, you get the last one.
Well, it's not quite adding the two middle numbers. It's you're multiplying the middle numbers together and then doubling them. So you're thinking join these together?
Right.
Is that, yeah. You gotta be a little bit careful. Like, how would you join these together?
Right.
Is it 5x or is it 6x when you join them together? What's that?
You'd add the 3 and the next 3. That's what I mean.
Oh.
The inside terms.
Okay.
Both of the last terms.
Okay.
You're smart.
Okay. So we'll get to that in a minute. I'll show you how it works. But here you would have x squared as the first term. What's the last term going to be for this one?
2.
Positive. Well, you got to multiply. I think you're adding them.
Oh, right.
So negative 1 times negative 1 is 1, and then in the middle it's going to be minus something. So you go like this. This is negative 1x, and then I have to multiply it by 2. So negative 2x goes right here. So
Ray, how do you get the 1?
That's weird.
negative 1 squared is 1.
That's weird.
Negative 1 squared.
Oh.
Here's how it works when this is not just a simple x here.
Do we
That's
do
weird.
it this way or can we do the box?
You can do the box if you like, but
Bird box.
we'll see. When you finish the classwork, like,
Mr. Ram, have you seen bird box?
so 2x right here, what's 2x squared going to equal? If you square this, 4x squared, right? What's the last term on this going to be? 9. Now here's a little trickier here. These two together multiplied equal 6x. And then you got to multiply that by 2. And you end up with 12x. So you should get a 12x as the middle term. So when we combine those two together, we're combining them by multiplication and then doubling it.
Yeah, Mr. Brown.
So what are the 4 terms here, or 3 terms here going to be? What's the first term for this guy?
Look at Brady.
What's our first term here?
What?
What's our first term on this guy?
6x squared.
6x squared.
You're multiplying on that.
6x squared.
3x times 3x.
Oh, 9x squared.
9x squared.
What's the last term going to be?
Plus something.
Plus 16, good.
Plus 16.
What's the middle term going to be here?
It's 8x.
No.
No.
You can't just double this. That,
12x.
okay, but 12x is got to be doubled.
Negative 24.
Negative 24x, yeah. The 12x is what you get when you multiply these two together. You get the negative 12x, but then you got to double that. Remember in the box,
That's weird.
it's this spot and this spot are exactly the same, and they're both going to be negative 12x here and here.
That's weird.
And so you're going to add the 2
Yeah, that's right.
and get the middle term. Okay.
That's right.
So that's squaring a binomial. There's one other little shortcut here, going back up. Did we get this written down?
That's weird.
No. I wasn't paying attention. I'm sorry.
At least you were honest.
Honesty is the best policy. I'm done.
So if you go back to these,
Yeah.
we're going to notice a pattern as we do the little box. We're going to do the box first. So we have x plus 2 times x minus 2.
Yeah.
And that's going to give us an x squared in the top left. X times 2 is 2x in the top right.
That's weird.
X times negative 2 is negative 2x in the bottom left. And then negative 2 times 2 is negative 4 in the bottom right.
That's weird.
Okay.
Negative 2 plus positive 2.
That's
So when I go to add these together or combine like terms, what happens to the middle term? It disappears. When does that happen? It didn't happen on the last example I did, but what's different about this one from this up here? Yes, the subtraction sign is the difference. So this ends up equaling x squared minus 4. It's called a difference of squares, quadratic
Okay.
binomial.
But why is 2 and negative 2 and negative 4? Good question.
Great.
Why is 2 and negative 2 negative 4? Because when you're multiplying them,
Oh, okay, you're multiplying.
I'm adding them here.
Oh, wait.
So,
Silly mistake.
okay, if
Yeah, that's why your Snapchat story worked.
okay, guys, based on what we're seeing right here, what's going to happen with this guy? What's the first term going to be?
That guy's gonna be like.
X squared.
Yeah.
What's the last term going to be? And what's going to happen to the middle term? Cancel out. Now, here's what you got to be aware of, and it goes like I have pre-calculus students that would fall into this trap. It's easy to assume that these are the same. They are not. It's easy for students to say this is equal to x squared plus or minus 25. It depends on. But this has a middle term. This does not. So let's review just quickly. When does it have a middle term?
When they're both positive.
When they're both positive or both negative, and when they're the same. Here, we don't have a middle term when they're almost the same, but they differ by just a sign. So they are the same terms, but a different sign in between. Keep that in mind here. So let's see if we can apply that rule here. That you guys, if you understand this, you can be done with the class right now.
I'm still lost in this.
10 minutes. She's already doing it. Don't do that yet. Wait. If you wait, just wait and watch here. Because there are a couple of tricky things that come up in these bottom two here. So the top one, what's this one going to equal using our little shortcut?
2. No.
X squared minus 9. So the x times the x gives me the x squared.
Yeah.
The negative 3 times the 3 gives me the negative 9. What happened to the middle terms?
It's not.
Yeah, one of them was positive 3x and one was, and they canceled out. Okay. What about here? N squared minus 36. And it's as easy as that.
It's just easy, huh?
Now this is a little different.
It's a trickster.
What's the first term going to be?
Except for K.
X to the 4. And then the second term is?
Minus 64.
Okay. Now, I need everybody looking up here. You guys cannot be going forward on this yet. Don't go forward on this. You need to look at this one.
Ian goes forward, guys.
Everybody looking up here. Okay. Why can I not use this little shortcut on this one? What's wrong with it? Yeah, Sarah, do you see? Yep, she's right. These have to be exactly the same, and they are not. Okay. So what do?
You would have to.
You have to foil it, or use the box, whatever. So you'll have. Here's my assumption. This could be wrong, but I feel like those who are using foil are probably make the transfer to the box just fine. It's the other section. So if you're using foil, awesome. That's kind of like I think in terms of foil. So 2x squared plus 5, 2x minus 5. So walk through this with me. You ready? 2x times 2x squared.
4x squared.
No, not squared.
Oh, 4x.
4x to the third. 2x times 5.
7x.
10.
Oh, 10x.
So negative 5 times 2x squared.
Negative 10x.
Oh, I was right.
There are also deductions for if you're really annoying during class. That automatically deducted. Taken away. So negative 5 times 5.
Negative 25.
Negative
I'm so smart.
Not yet.
It is water.
So look at this, guys.
Is water.
No, don't.
Yes.
Just wait.
Toss it. He's swimming.
Hand it to him.
Oh,
Okay, so guys, right here, there are no like terms in this box. If I did FOIL, none of the FOINL would be like terms. So my final answer is 4x to the third minus 10x squared plus 10x minus 25. And that's it.